All right, welcome. Today we're going to be rationalizing the denominator. We're going to be talking about fractions. It's also called moving a root. Our goal is to identify when the denominator of a fraction is not rational and move the root from the denominator into the numerator only. And we're mostly going to be dealing with square roots. Let's get started. So we're going to recap the parts of a fraction. So here's our fraction, x over y. This little guy is called the vinculum. That's the bar between the numerator, number on the top, and the denominator, number on the bottom. Hopefully that refreshed your memory. Vinculum might be a new term for you. Let's review types of fractions. All my heaters just kicked on at once. We have proper fractions. That's where the numerator is smaller than the denominator. Some just examples: 4/5, 6/8, 131st. Okay, we have improper fractions. That's where the numerator is larger than the denominator. 5/4, 8 halves, 8/2, or 131/3. Then we have mixed numbers. That's when you have a whole number part, an integer, and a fraction where the fraction component is a proper fraction. You often see this as a when you do long division. So we got 4 and 4/7, 8 and 3/8. Those are just a couple examples of what those might look like. We're mostly going to be dealing with improper fractions and proper fractions here. Okay, so now we have a square root, or root, in our denominator. And here we have x and y are any integer. We're just going to use integers for now. And y cannot equal 0. You see why that would be a problem. We cannot divide by 0. Bad things happen. The universe implodes upon itself. We're going to avoid that. So we do not want the root in the denominator. How do we get rid of that? Well, we just multiplied times 1, but we're going to choose a 1 that suits our needs. We're going to choose a 1 that looks like the square root of y divided by the square root of y. Anything divided by itself is 1. So this whole thing is just 1. But we choose it so it gets rid of the root in the denominator. When we multiply fractions, we multiply straight across. So in the numerator, I have some number x times the square root of y. And then I have the square root of y, which we'll write that using a rational exponent, just to illustrate what happens here, times the square root of y, and we'll use a rational exponent. Here we have the product rule. When I multiply two numbers and the bases are the same, I'm going to add the exponents together. So I have in the numerator x times the square root of y, and I have y to the 1/2 plus 1/2. And we don't need to keep the exponents there. 1/2 plus 1/2 is y to the 1. So let's rewrite that so it looks a little neater. Why can't I erase that y? That's interesting. Yeah, we just leave the exponent out of it. So I have x times the square root of y divided by y. Let's see this process in action with actual numbers. So 4 over the square root of 5 equals what? Well, let's take that and we'll multiply it. Multiply the numerator and the denominator by the square root of 5, which is just square root of 5 over the square root of 5, which is just 1. So it doesn't change the value of our fraction, just gives our fraction a facelift so that these two guys cancel out, the square roots go away, and I just have 4 times the square root of 5 over 5. This fraction is equivalent to 4 divided by the square root of 5. It just looks different because we do not want the radical in the denominator. Let's see another example. 14 over the square root of 7. I'm going to multiply the numerator and the denominator by the square root of 7. So I have the square root of 7 over the square root of 7. Remember, this is just 1. Anything times 1 is itself, so this doesn't change value. It just changes appearance. So I have 14 times the square root of 7, which is in the numerator. Remember, we multiply straight across. And then in the denominator, these two cancel out. The radicals cancel out, and I just am left with 7 in the denominator. But I can simplify this fraction. They have a common factor of 7. So I have 1 left over in the denominator and 2 in the numerator. So my final answer is 2 times the square root of 7. This might look complicated, but if we just do the same thing we've been doing, and we understand how we can multiply square roots, we'll be fine. So I'm going to multiply the numerator times the square root of 3, and the denominator times the square root of 3. This is 1, okay? So we're going to rewrite our numerator as 2 times the square root of 2 times the square root of 3. And the denominator, I have 3 times the square root of 3 times the square root of 3. Okay. So I'm going to simplify the numerator. I have 2 times the square root of 6 because I have root 2 times root 3 is the same as root 6. And then these, square root of 3 times square root of 3 is just 3. So I have 3 times 3 in the denominator, which is just 9. Final answer. I can't simplify the fraction anymore. We're done. So to recap, rationalizing our denominator means we are going to multiply. Let's use our example with letters here that stand for any number except y cannot be 0. We're just going to multiply the numerator and the denominator by the square root of y, the square root of whatever number is down here. And that puts our radical in the numerator, and it cancels it out of the denominator, and we're just left with the radicand. Okay. The reason we do this is because this is a rational number. This is not rational. So we want to have a rational number in the denominator. That's why we call it rationalizing. We're just moving the root from the denominator here into the numerator. So if you're in my class, your assignment will be the rationalize fraction worksheet. Hope this video has been helpful. If you have any questions, you know how to get a hold of me, you know how to find me. Good luck.